Instantaneous velocity can be defined as velocity at that particular moment or at that particular instant. Okay. So before going to define instantaneous velocity, let's define average velocity again. Can be defined as displacement by total displacement by time period. This is the definition of average velocity. Mathematically, it can be written as x2 minus x1 divided by t2 minus t1. x2 minus x1 is the definition of displacement. Time period is t2 minus t1. This x2 minus x1 is the change in x. Change in x is represented as delta x by. This is change in time, that is delta t. That represents the change. If this change is too small for very small time period, that means delta t is very small, tends to 0, then this delta x by delta t becomes dx by dt. That is called instantaneous velocity. Okay. So instantaneous velocity is the derivative of displacement with respect to time. Just remember this. Okay. V instantaneous is dx by dt. This can also be defined as slope of the curve xt. If you have a curve like this, graph between x and t, slope of this graph at any particular point is dx by dt. Okay. So this instantaneous velocity can be defined as slope of the curve between x and t. We will discuss about these graphs and slopes in a particular video, in a separate video. As of now, remember that V instantaneous is derivative of x with respect to time. Let's see few examples on this. X equals to t square minus 60. Find the velocity at t equals to 4 seconds. So he is indirectly asking instantaneous velocity at 4th second. Okay. Instantaneous velocity can be defined as v equals to dx by dt. That is d by dt of x is t square minus 60. This will become t square of derivative of t square is 2t minus derivative of 60 is 6. That is dx by dt. He is asking instantaneous velocity at 4th second. At t equals to 4, it becomes, put t equals to 4 here, 2 into 4 multiplied by 6, it becomes 8 minus 6. That is 2 meter per second. V is 2 meter per second. That is instantaneous velocity at the 4th second. X equals to 3t square plus 2t plus 6. Find the velocity at t equals to 2. That means he is asking instantaneous velocity at t equals to 2. And also find average velocity between t equal to 2 to t equal to 4. Here we have two questions. First one is to find instantaneous velocity. Instantaneous velocity defined as dx by dt. Dx by dt, d by dt of 3t square plus 2t plus 6. This becomes 3t square becomes 60. After derivative, this becomes 2. Then dx by dt at t equals to 2 is, put t equals to 2 into this, 6 into 2 plus 2, this becomes 12 plus 2, 14 meter per second. That's the instantaneous velocity. The second part of the question is find average velocity between t equals to 2 to t equals to 4. Average velocity formula is x2 minus x1 by t2 minus t1. T2 we know T2 is 4, T1 is 2, but we don't know x2 and x1. So put t equals to 4 into this, that becomes x2. T equals to 2 into this, that becomes x1. First find x2 and x1, then substitute into this. x2 is at t equals to 4, 3t square plus 2t plus 6. t equals to 4. Put t equals to 4, this becomes 3 into 4 is 16 plus 4 plus 6, 62. X2 is 62. X1 is at t equals to t2 is 4, t1 is 2. That is 3 into 4 plus 2 into plus 6. This after solving this, you will get x1 is 22. We know x2 and x1. Then find average velocity. X2 is 62. X1 is 22. Average velocity equals to x2 minus x1 divided by t2 minus t1. That is x2 is 62 minus 22 divided by 4 minus 2. That's equals to 40 divided by 2, 20 meter per second.